हेलो एवरीवन। आज हम लोग देखेंगे कॉम्प्लेक्स नंबर पोलर रिप्रेजेंटेशन. We are going to study today Argand plane and polar representation of a complex number. All right. So Argand plane हम लोग समझते हैं कि क्या है एक्चुअली. जैसे हम लोग ने कार्टेशियन कोऑर्डिनेट्स, जैसे कोई कार्टेशियन प्लेन पढ़ा है ऑलरेडी जूनियर क्लासेस में, जिसमें एक्स एक्सिस वाई एक्सिस होता था और ये जो पॉइंट ऑफ इंटरसेक्शन होता था तो ये हमें यहाँ पे सारी वैल्यूज़ ज़ीरो हो जाती थी. जो भी एक्स की वैल्यूज़ हैं वो ज़ीरो हो जाएंगी, जो भी वाई की वैल्यूज़ हैं वो ज़ीरो हो जाएंगी. सो राइट डायरेक्शन में जाएंगे एक्स पे तो पॉजिटिव वैल्यूज़ 1 2 3, लेफ्ट में जाएंगे तो नेगेटिव वैल्यूज़ एक्स की, वाई ऊपर जाएंगे तो पॉजिटिव, नीचे जाएंगे तो नेगेटिव. ठीक है. it is used to actually just represent the address of that point. Let's say I have to say uh, where is the point actually lies on this plane. This Cartesian is actually the plane which is having x-axis and y-axis, and let's say the point is here. So how will I tell somebody that which point I'm talking about? So I'll tell to him or her the address of that point. So to make us able to represent that point A with some detail, we are going to write it in address form. So in Cartesian plane, the first number will be your x, or you can say it is called as abscissa. It will be related with the x axis, x coordinates. Next is y will be this y will be called as coordinate. Let's say what will be x and y here. See, ये point जो है, if I draw a vertical line passing through x axis, so what this line is meeting on x axis at what point? At 3. Similarly, if I draw a horizontal line parallel to x axis, so this point, this line is meeting y axis at 4. So address of this point is 3, 4. All right. So similarly, we are going to represent, see, a complex number is also a point, and we will represent that point on a plane. That plane will be called as Argand plane, or you can say complex plane. It is a simple plane which is representing a simple number, a real number. But complex number we are going to represent with the help of plane which is known as Argand plane. So it is very similar to this Cartesian plane only. In complex, or you can say in Argand plane, we have x-axis. This x-axis is called real axis, and this y-axis is called imaginary axis. All right. Let's say these numbers are there on x-axis, means on real axis. It is similar to Cartesian plane only, but here on y-axis only imaginary numbers will be there. All right. So this will be I in the positive direction, next will be 2i, other will be 3i, like this 4i. Okay. Similarly, when we go down, now this point of intersection is known as, in Cartesian plane it is called as origin. Where the coordinates are 0, 0. But in complex plane, this point of intersection is known as pole. Here also both the numbers, the real number and the imaginary number, will be 0 at this pole. Similarly, the imaginary axis as goes up, that is positive direction, it will go down from the pole, that will be negative imaginary number, or you can say minus I, minus 2I, like this. Very easy. Now how to show that number, complex number, on this Cartesian plane. So I'll draw for you a big one so that it is clearly visible. So let's say I have to represent 2 plus 3I. This is your complex number. Fine. Now the real part you will take on x-axis or on real axis. So this imaginary part will be actually the coordinate of x, or you can say x for the real part or real axis. On imaginary axis, now since I is there, it means it is imaginary part, so you have to see what number is present here. So this will be taken as y coordinate, or here. So if I draw a complex plane or Argand plane, x, y, 1, 2, 3, I, 2I, 3I. Now what is x? 2. So I'll draw a line perpendicular to 2 like this. Okay. What is y here? Means what is imaginary part? The numerical part of imaginary here. This is imaginary part. So what is y here? I you don't have to include because I is already there. So here 3I is there, no? So this is I, this is 2I, this is 3I. So from here you will draw a line, horizontal line. You will see a point of intersection where these two lines are meeting. That point is actually your complex number, z as 2 plus 3I. So it is very much similar to the Cartesian coordinates, where first part, or you can say, you can write this as z means your complex number, because this is imaginary axis. So any point will be your imaginary point there, or imaginary number is there. So z, what is the x coordinate? 2, comma, what is the y coordinate? 3. All right. So now how will you identify it is a Argand plane or a simple Cartesian plane? You will see this y-axis. If I are there, present there, it's your imaginary axis. Then this point will be written as this. Okay. Don't say that it is a simple point. No, it's not a simple number, because we are representing this point where? On the Argand plane. So that will be your complex number. All right. Now what is actually here? Argand plane must be clear. It's a plane on which we represent the complex number. Let's see what is polar representation actually. See, again the same thing we are going to do. X and y axis we are going to draw. All right. X and y axis we are going to draw. Fine. This will be x. It is real. This is y. This is imaginary part. And this is pole. Let's say I want to tell this point. I want to represent this point in terms of angle, which is going to be represented with theta, and the distance, the shortest distance of that point from pole. In these two terms, let's say it can be any number. Okay, let's say I'm writing it r. So we will understand what is theta and what is r right now. So I want to represent this number, or sorry, this complex number, it can be anywhere on this complex plane. Alright, so I want to represent that number, that complex number, with the help of two things. One, the angle, or you can say angle of rotation, and the second is distance of that point from pole. So consider that there is a let's say an arrow which we rotate in anti-clockwise direction. Let's say it is here till here. Right now the angle of this arrow with x-axis is 0 because it is lying on that x-axis itself. Let's say this is A, okay, and this is O. So OA is lying on x-axis. So right now the angle of this OA ray is what? It is actually, or you can say OA line segment. So it is actually lying on x-axis. So the angle between OA line segment and x-axis will be 0 right now. So let's say I rotate this OA line segment. Alright, if I rotate this OA line segment, keeping this endpoint fixed, and this will move like this. So let's say I am getting this line segment here. Let's say this is A, and by angle how much it has been rotated? Theta. So I want to write this point in terms of theta and r. In terms of theta and r. So I had already told you what is theta. What is theta? Theta is actually the rotation. How much this rotation, or how much angle is there between this line segment with x-axis. Fine. It can lie, the theta can be like this also. It depends where the rotation has stopped. So let's say the rotation of this line segment has stopped here itself in the first quadrant. So this angle will be your theta. Now what this distance will be actually? Let's say some point is there, x comma y. Alright, it's a point A. So this distance will be what? It will be actually root of x square plus y square. How? If I draw a perpendicular from this point A, so OA, let's say this is B. So OAB is a right angle triangle. Using Pythagoras theorem, this OB will be how much? This OB will be how much? X. And this AB will be how much? Y, because it is similar to this length. So using Pythagoras theorem, this OA will be called as hypotenuse. So the length of OA will be how much? Root of base square plus height square. So here r is actually what? R is root of x square plus y square. Now in the previous part we have seen that this x comma y is actually the complex number. Why? Because I am representing this on a complex plane. So can I write this this point as x plus iy? Yes, obviously we can write it down. So we have learned how to find out the mod of any complex number. Mod is actually what? Root of real part, square of real part plus square of imaginary part. So can we say that this r is actually the mod of that complex number? Alright, so one thing we came to know, that r is actually the mod of complex number. Now theta, by which this theta, OA has turned in the anti-clockwise direction, that is theta. So this theta will be called as amplitude. Alright, this theta will be called as amplitude. Now here one more thing we need to represent. If this complex number is represented x comma y, but what did I say in the starting? I have to represent this complex number in terms of theta and r. So if this length is r, so how much will be this one? Using Pythagoras, using the in class 10th you have done that trigonometry chapter. There you have seen the x component of particular line and y component of particular line. So this length is r. So if I take this component, horizontal component, so this will be what? R cos theta. So we can say OB is what? R cos theta. And actually OB is what? X only. So we can say x is actually what? R cos theta. Fine. Similarly y will be what? The y component of this r. So y is actually what? Or you can say AB. AB is r sin theta. So this AB is what? This is r sin theta. So r sin theta is how much? Y only. So we can say y is equals to r sin theta. Yes or no? So x is equals to how much? R cos theta, and y is equals to how much? R sin theta. So we can write this point as, or this complex number as, z equals to x is how much? R cos theta plus I, y is how much? R sin theta. So take r common, we can write cos theta plus I sin theta. So this is actually the polar representation of a complex number. Now we will do one question based on this. We will try to represent any complex number in polar form. So let me take one example. Let's take this one, z as 1 plus I root 3. Okay, so let us write this complex number in polar form. So as we know that the polar form of the complex number is what actually? R cos theta plus Ri sin theta. Alright. Here if I say this r cos theta is actually nothing, it is equals to this one only, 1, because r cos theta is actually the real part of the complex number. And this root 3 is actually nothing, it is r sin theta. Now how to find out this r? Let's say this is equation 1, this is equation 2. We will do the squaring on both the sides and add both the equations. So if I do squaring on both the sides, I'll get 1 square equals to r square cos square theta. Here also this also will be squared on both the sides, so it will be root 3 square is 3 only, r square sin square theta. Now we are going to add them. So when we add it, we get 1 plus 3 equals to r square, we can take common, cos square theta plus sin square theta. Cos square theta plus sin square theta is actually 1. So ultimately what we get? We get 4 equals to r square. Now it has two possible values. R can be your plus minus 2, but since we are representing the complex number in polar form, so r is nothing, it is mod of z, means mod of the complex number, and mod value can never be negative. So therefore what value we are going to take for r? Only positive one, that is plus 2. Now r we found out. Now what is left to find out theta? We are going to put the value of r here itself and we'll find out the theta. Alright, so r we know now, r is 2. Put again the value of r in this first equation, you will get 1 equals to 2 cos theta. So this implies cos theta is equals to 1 by 2. So we have done this in what will be the theta? Theta will be cos inverse half, or you can say cos 60 is actually your theta, this 1 by 2. Okay, in class 10th you have done this values. So here we can say theta is actually nothing, 60 degrees, but when you are going to represent in polar form, you have to represent this theta in radians. Alright, So 60 is nothing, it is pi by 3. So now we know that this polar form we can write like this: z equals to r is how much? 2 cos pi by 3 plus 2 I sin pi by 3. We can take 2 common from both the terms. It will be 2 cos pi by 3 plus I sin pi by 3. So our basic thing was here to tell you what is complex plane, fine, how to represent a complex number in polar form. Polar form is actually this one. This is the formula, or you can say this is the representation. First we'll find out r. R cos theta will be real part and r sin theta will be imaginary part. Assign those values whatever is given in the question. Do the squaring on both the sides and add two equations. From there you will get r as whatever here you have got it, that is 2, and then you will put the value of r, and then correspondingly you are going to find out the value of theta, and you have to put both the values in this form. You get the the polar form of the complex number. Alright, so I hope you have understood. Thank you, and keep studying hard.